Okay, this is McGraw-Hill Chapter 6, Section 1. This is dealing with radicals and complex numbers. First thing it does here is it defines what a nth root is. Make sure you understand that b is the square root of a if a is equal to b squared, meaning, like for instance, if you put 4 here and square it, you can get 4, so a would be 4. So here, the square root of 4 would be plus or minus 2. If you're looking for the principal square root, it's only the positive. Remember, you can have a negative outside a square root, but you cannot have a negative inside. It's not a real number. And then also the square root of 0 is equal to 0. Example 2, just some basics. Square root of 36 is a perfect square, so it becomes plus or minus 6. Square root of 4 over 9, we put square root of 4 over square root of 9. Square root of 4 is 2, square root of 9 is 3, so it's plus or minus 2/3. Square root of 0.04, in order to get to 2 decimals, we have to have 1 decimal here, so it's plus or minus 0.2. Come to example 5. We have the fourth root of negative 3 to the 4th power. Then the root and the power cancel each other out, becomes an absolute value, becomes 3, because it's an even power. If we have the same situation where it's an odd power, the negative sign stays and it becomes a negative. Remember, even powers always give us a positive. Odd powers can give us positive or negative. If we have the square root of x plus 2 squared, the little 2 here divides into here and gives us just x plus 1. If we have cube root of a plus b3, this 3 divides into this 3 and gives us 1a plus b. Here we have square root of y to the 4th. So what happens is there's a little imaginary 2 out here. So the 2 goes on the bottom of the fraction, 4 goes on the top, 4 over 2 gives us y squared. Here's a better example of these. This is example 6 on page 501. You have square root of y to the 8th. So if we put this little imaginary 2 here, the little imaginary 2 goes on the bottom of the fraction and the exponent. 8 goes on the top. 8 divided by 2 is 4, so it's y to the 4th. So square root of y to the 8th is y to the 4th. Same thing here. We have cube root of 27, a to the 3rd. So what happens here is we change 27 to 3 to the 3rd. Now this little 3 divides into this 3 and gives us 3. This 3 divides into this 3 and gives us 1a. So remember, I'm not going to give you any radicals higher than cube root. 4th root, 5th root, I'm not going to give you. So you got to know your perfect squares, you got to know your perfect cubes. But basically this little number here out with the radical divides into any exponents inside, and that's how you get your answer. So 3 divided by 3 gives me 3 to the 1st, which is 3. 3 divided by 3 gives me a to the 1st, which is a. Here's a better example. I can square root of 25, a to the 6th, y to b to the 4th. And so what happens here is I change 25 to 5 squared. Still have a to the 6th, a to the 4th. So if my 2 divides into here, it gives me 5 to the 1st, which is 5. If I did divide this 2 into here, it gives me a to the 3rd, which is a to the 3rd. If I divide this 2 into here, I get b to the 4th, which is b squared. Last example problem deals with the Pythagorean theorem. Make sure you understand Pythagorean theorem only works with right triangles. C is the larger side, it's the hypotenuse. Doesn't matter if you put a here or b here or reverse and put b here and a here. There's going to be the same. Pythagorean theorem says that if I take a and I square it plus b and I square it, it's going to equal the bigger side, c squared. It's another way to determine if a triangle is a right triangle. If you take the larger side and put in for c and the 2 smaller sides and put it for a and b and square them, you should get the same number on both sides of the equal sign, which would prove that it's a right triangle. Here's the problem. It says solve. We've got 5 in for one side, a. We've got 13 in for the hypotenuse, c. We're trying to find b. So we substitute the 5 in for a, 5 squared. Keep the b squared. Substitute the 13 in for c, 13 squared. Square it, we get 25 plus b squared equals 169. Subtract the 25 over, we get b squared equals 144. Take the square root of both sides, and we get b equals 12. In this type of problem where it's a real world problem, we always want to solve for the principal square root. it's an algebraic problem, you solve for both plus and minus.